In this video, we will solve CSIR UGC NET 2019 June Physics problem 17 out of the 55 problem for the question. We have covered all 16 questions before, so this is the 17th problem. Okay, so the problem goes like this. The element of a 3x3 matrix A are the products of its row and column indices Aij equal to Aij, where Ij is 1 to 3, the eigenvalues of A are. So how do you solve this kind of a problem? So we have A equal to, it says Ij equal to Ij, so this is 1 1, this is 1 2, this is 1 3, and then this is 2 cross 1, so 2 4, 2 cross 3 is 6, so this is 3 6 9, right? How do we get this? So each of the element is basically the product of I cross j. So this is 3 cross 3, which is 9. I hope you get it, right? Okay, now what is the rank of this matrix? If you subtract this from this from this, and then again this from this, you will ultimately get a rank of 1, right? So the rank of the matrix is 1. What does this mean? It means that two of the eigenvalues must be equal to 0. So if the eigenvalues are lambda 2, lambda 1 and lambda 3, lambda 2 will be 0 and lambda 3 will be 0, and we need to find the lambda 1. Now we know that the trace of a matrix, so the trace of A is the sum of the eigenvalues. Then if we take this matrix, we can write that 1 plus 4 plus 9, which is the trace of the matrix, is equal to 0 plus 0 plus lambda 1. So this is the eigenvalue. So this is lambda 3, lambda 2, and this is lambda 1. Okay, and if we simplify a bit, so this is 14 equal to lambda 1. So the answer is the eigenvalues are 14 0 0. So this is the correct option. This kind of problems are quite easy to solve. Generally students tend to ignore this kind of problem because it takes time, but you can see that this kind of matrix is quite easy to solve, and the rank of the matrix is 1, so you know that there is only one eigenvalue, and you can directly mark the answer if you are running out of time. So that's it. If you like this short video, do subscribe to our channel, ring the notification bell, do comment if you have any suggestions. Thanks for watching and take care.